Hello, my name is Andre, and today I'm going to show you a new feature of Talos 0.9, the shared, or how we call it also, virtual IP for the control plane, when Talos automatically provides an IP address, which basically floats between the control plane nodes, depending on the health, and at any given point in time, only one node owns that IP address. Let me get to the demo. So I have a Talos cluster here, which consists of three control plane nodes and one worker node. This cluster is running for me in Kimu, but that doesn't matter. We have like the IP addresses for the control plane nodes are 2, 3, and 4. And I have it configured for virtual IP. Let me show that. In the machine configuration, there is a virtual IP .50, which is going to be assigned to one of the control plane nodes, and it will be used as a control plane endpoint. Uh, we can find that in a moment. Here it is. It's the control plane endpoint. So it's the one which is used for Kubernetes requests. So this feature basically removes the need for any external load balancing solutions in these simple scenarios. So I have my screen split into four parts. On the left top part, I will be giving out comments. On the right top part, I have an output of kubectl get nodes in a watch loop, so we can see that the control plane is now up. It gets updated every 2 seconds. In the bottom right corner, I'm going to show you how to see which node at the moment owns the virtual IP. So I have a comment here, which is basically talosctl over with the list of nodes, all the control plane nodes. I'm using the interfaces comments to get all the IPs assigned to the node, and I grab for my IP .50. So I can use that to see that at the moment, this IP .50 is assigned to the node master1, which has the IP address .2. That's the initial state. So let's try to do something with the cluster to see how this virtual IP moves to another node on failure. Like first of all, in this like bottom left terminal, I'm going to launch the command to get the logs of the network D service on these control plane nodes, as I'm interested to see how this virtual IP is going. I'm just tailing them in the follow mode, so we'll see the new lines as they get added. So let me reboot that first node, master1, which owns the virtual IP at the moment. I'm going to reboot it. And we can see how the virtual IP is going to move to a different node. Oh, sorry, I typed the IP address incorrectly, just missed the 2. Um, so I entered reboot. The first node immediately entered the reboot cycle. We can see that virtual IP got immediately moved to a different node, .3, which is master 2 in my case. And the kubectl output is still working fine, which means that control plane access goes uninterrupted. There was no interruption. Basically, and in the network D logs, we can see that the first node, master1, gave up on the shared IP, and the node master2 immediately picked up the shared IP, and now it owns that. So at the moment, the master1 node is rebooting. When it goes back up, the IP will still stay on the node which owns it, the master2, but when it goes back up, I want to show you the another feature of that. I'm going to try to, like reboot was a graceful operation, so it was really that the Talos node knew that it's going to be rebooted, so it first gave up on the shared IP and it got immediately assigned to a different node. Let's try something else. Looks like master 1 got rebooted. So I'm going to simulate a hardware failure. As all my nodes are running in QEMU, I can do that by just simply sending the stop signal to the process. So first of all, let me restart this log tail thing. So I can find my QEMU for the master 2, the one which owns the IP address at the moment. That's the process PID. So I'm going to send it the stop signal, which means that the QEMU process will be stopped and my virtual machine will be virtually stopped as well. So it will stop responding to requests. Um, and at this moment, the control plane is in fact like affected because the virtual IP is still owned by the node dot master2, right? But this node is no longer responding, so the actual output here is not updating. We can see that the timestamp got stuck. So we need to wait for the timeout to elapse so that the other node will pick up the virtual IP. You can see that there is an error here, right? It can't connect to the endpoint because that node went down. Let's wait a bit. It should be around a minute before another node picks up this IP. So this coordination of the virtual and shared IP is based on the etcd. So as the control plane nodes run the etcd cluster, they use the etcd cluster to see who should own the IP address. And you can see that it's back. Now node master 3 picked up the virtual IP. My kubectl output is working correctly. And this command should get updated here as well anytime soon. It should show us, it's because this one node is not responding at the moment. I just removed that from the output. Yeah. You can see that the master 2 now owns the virtual IP. And even if I resume the execution of my failed VM, the virtual IP will still work correctly. You can see that the node which I resumed, it kind of woke up and immediately realized it lost the session and removed that share IP. So even though the VM came back, it immediately knows that another node owns the virtual IP, so it removed from its own interface so that it doesn't disrupt the traffic, and we still have a single node which has the virtual IP, and our control plane should come uninterrupted. It will take like a few seconds because of the ARP announcement for this thing to clean up, but the control plane will get back to normal. And we can see that the virtual IP address is owned by a single node. Yeah, control plane is back. So this feature allows us to build a control plane endpoint without external load balancer. We can see how it handles the graceful failures like node reboots, and also like hard failures, like a hardware failure when node becomes completely unresponsive, and it still can notice that and move the IP to the healthy node. Thanks for watching. Documentation on this feature will be in this video description. Bye.